how's that? Oh, well, hang on here. There we go. Okay, so what we'll do is we'll just go right into blocks of these. Let's see, I might need a little bit of, I don't have a syllabus right handy with me. So the first, on page 165, which ones are we doing there, Maria? 1 through 17. Okay, so that's what I was thinking. Okay, so we're just going to kind of block them out until they kind of change. So 1 through... let's look at about 1 through 7, right in that area. We'll do one of those, okay? And then that kind of will show you how to do that one. So somebody want to pick one out of 1 through 7. It doesn't matter. They're all kind of the same. Pick one out and we'll do it. 1 through 7. Give us a lucky number. 6. 6 is the winner right there. Okay, we're going to do number 6. All right, so when I'm doing these, I'm just going to kind of read through them a little bit, figure out what it's asking, and then we'll go from there. So it says the product of 8 and a number is 272. Find the number. Okay, so what we want to do is write an equation and then solve it. They want you to write an equation. It's a good idea that you do that, and then we're going to solve it. So product is the key word there. What operation is that? Multiplication. So I'm going to take the number 8. All right. Product means I'm going to multiply that in a number, so you can pick any variable you want. You can pick x and z, doesn't matter. And equals is 272. So that would be the equation that you want to write. It's going to look like that. Okay, 8x equals 272. The product of 8 and a number is 272. So now that I've written that, I just got to solve it out. All right, it's a one-stepper, so we just got to divide by 8. And I'm not sure what that is.
34.
There we go. Okay, so the first 6 and the one after are all like that. All right, all you're doing is reading it, looking for that key word, figuring out what operation it is, writing the equation, and then solving it. All right, that's what we're doing there. Okay, so pretty much that's those. Let's see, let's pick another one. 8 through 8, 9. He wants 9. That's fine. We'll do number 9. All right, here we go. Number 9. So the sum of 4 and twice a number is 56. Find the number. Okay, so again, we want to just kind of look at the key words. We see the word sum. What operation is that? Adding. So it says the sum of 4 plus twice a number. So what does twice mean? What does it mean by twice? By 2. So we're going to go twice a number. So again, we got to pick a variable. Doesn't matter what you pick. I'm just going to pick x. Twice a number is always equals 56. So there's my equation. 4 plus 2x equals 56. Sum of 4 and twice a number. Again, sum is the plus. Now I just have to solve it. It's a two-step equation. We should be really good at that after you did a whole bunch of them. There we go. And then 26. All right, so you write the equation, then just solve it out and get the answer. That's all they're going to be asking you to do on those ones. Let's try one in the 14, 15, 16 area. So 14, 15, 16, we need a number out of that one. We got 14. Okay, number 14. So far, not too bad. A number increased by 12 is 4 times the number. All right, so now we have the word increased. What operation is that? Addition. Okay, so we're going to pick a number. We need a variable, so I'm going to pick x again. A number increased by, so what am I going to write? Increased by, so what operation did you say it was? Add, so it's going to be x plus 12 is means equals 4 times the number, so obviously times is multiplication. So we have to go 4x, I heard someone say. All right, now there's my equation. Okay, so all I had to do is just kind of take it, take a deep breath, relax a little bit, read it, look for those key words, kind of understand what it's saying. Now we're ready. We can solve these because, like I said, you're pretty good at this. So what do we do to solve this?
Subtract the x.
Yep, subtract that x. Move that over there. We're going to get 3x here, and then what is our answer going to be?
4.
It's going to be 4. So in these problems, what we're doing is we're writing the equations, okay, and then getting the answers. All right, that's what we're looking to do. Write the equation, get the answers. So the first one, we did 3 of them on there. The rest of them all follow that kind of technique. So if you follow that for those, you'll be fine. We did 1 through 17 of those ones, right?
Yes.
Okay. And then there's some after that, isn't there?
35, 38.
35 through 38. Okay. Okay. All right, so we're going to flip over to the next page there, problem number 35. All right. But 35, 36 are pretty much the same type of problem. And then we're going to take a look at 38, I think, or 37. We'll pick one. All right. So 35. American football field is a rectangle. And it says that the perimeter is 1,040 feet. I think that's what it says. The length is 200 feet more than the width. Find the width and the length of the field. So here's our rectangular field here. Okay. And the perimeter means the distance around it. So if we walked around it like this, that would be the perimeter. Okay. And what does it say about the length? What does it say about that length?
200 feet more than the width.
That's right. So we don't know anything about the width, right? So when you have a situation like this, that's always going to be your variable. So whatever you don't know something about, that's what's going to be the variable. So we want to let the width be whatever. So I'm going to make it, I can make it W. All right, and I'll make this the width. All right, I know this is also going to be a width because it's a rectangle, so they got to be the same. All right. So this is a width, this is the width. Okay, we're going to make it W. Okay, you can pick anything you want. I like to use a W for width. Let's see, what else is it saying here? We got 1,040 feet. We got a rectangle. We got perimeter. What does it say about the length?
It says that it's 200 feet more.
Then the width. Okay, so this length here, all right, right there, that length is 200 feet more than the width. So what could I write for an expression for that? What is more? What operation is that? Addition. So we're going to write 200 more than the width. Okay, so what I did when I was looking at this problem, all right, first thing I did was I drew a picture of a rectangle. A lot of times drawing a little picture helps. All right, I read it a couple different times. I figured out, well, what is it exactly that they're asking for, or I don't know anything about, and they're asking, or I don't know anything about the width. So then that's why I made that my variable. Then I went back through. It says here that the length is 200 feet more. So there's my key word more than, meaning addition. And now I have this. All right, you're thinking, aren't we done with this? Not done yet. Okay, so the perimeter we know is 1040. All right, and I said the perimeter is going to be if you walked around the rectangle. So let's walk around it. So we'll start in this corner. We'll walk around it. How far is this right here? I don't know if you can see where I'm drawing, but right there. How much is that? What did we say it was? W. Okay. Plus. Now I'm going to walk this way. How much is that? 200 plus W. There's somebody say, I got adventurous there. And then now we're going to walk here. So that's another width. Okay. Plus. Now we're going to turn around and walk back. Right. Okay, so in that, now we've written a equation for this problem. So we just kind of have to simplify it, grind it out, make it work. All right, so let's combine this up. So we got a W here, a W here, a W here, and a W here. So how many W's is that? 4. Okay, I got a 200 here, and I got a 200 here. So that's going to be 400. All right, so I'm going to pause just for a second. I want to make sure you see kind of what we're doing, because, you know, there's another one that you get to do, right? Okay, so now what we're ready to do, see, once you get to this point, you know, it's just solving an equation, all right? So that's all we're doing now is just solving this. So we'll move the 400 over to this side, okay? So let's see, 640 equals 4W. I'm going to divide by 4, and I'll get the width of that. I don't know what it is. 160. Now that I know what W is, I'm going to go back through and say, well, okay, I know what W is, but what was exactly they were asking? Let's see, they want to know, find the width and the length. Well, we found the width. All right, what do we know about the length? It's 200 more. So all I got to do is add 200 to this and get the answer. All right, so hopefully that kind of helped you. Drawing a picture, reading the problem a couple different times, looking for those keywords, figuring out exactly what it is that you don't know and what that represents. So when the problems get more complicated, that's what you're going to want to do, is be able to look at it and figure out, okay, what is it that I don't know? That's what I'm going to let my variable be, and what does it represent? W represents the width. Right? So I drew the picture, width. I didn't even do anything with the length, I just made it in terms of the width. That's a real classic sort of a math story problem there. All right. Any questions on that one and what we did? Yeah? No? Yeah? How did I get 360? Because the length is 200 more than the width. So we added 200 to it. Right here it says in there that the W plus 200. So that's what we did. Good question. All right. Yeah.
Well, should you put the feet after each number so you know it's in feet and not inches or centimeters or yards? Because the way it is now, it's just a number.
It's feet, huh? There we go.
Because I've been told before that if you don't put the exact what they're asking for, like the feet or centimeters or inches for that, the teacher will mark you down for it.
Well, this teacher won't. Okay. Because,
Because you're cool.
well, thank you, but you're really wanting some extra points. No, I'm just more interested you get the number, okay? You know, if you were if this was a real situation, you would probably know what those units are. Does that make sense? All right. So, and this just is not really a real situation.
Okay.
Okay.
Thank you.
Yeah. No, you're right. We need to do it, but I'm not going to mark it off. All right. I want to take a look at 37. This one here is a real tricky one. All right. It's kind of it's really a tricky one. You'll have one like 38 will be kind of like it. This says a bookcase is to be constructed as shown in the figure. The length is to be 3 times the height. If there's 60 feet of lumber is available for the entire unit, find the length and the height of the bookcase. They drew a picture for you, but I'm going to draw one anyway. Like this, okay? Now, this is a little bit confusing because they have no thickness involved. So, when I first looked at it, I thought, well, what about the thickness? Well, what they're talking about is just a 60-foot piece of board. Okay, that would be about the width of a shelf. So that's all you're going to worry. So we have a 60-foot board. Okay, big old board like that. I don't know how you're going to get that in your car. And then you're going to make this bookcase. All right, and we want it so that the length is 3 times the height. So what should we let our variable be? All right, let's go through it again. So the length is to be 3 times the height. All right. So we have a length and we have a height. Which one of those is going to be our variable that we don't know? Would it be the height or the length? What do you think? The height. Because we don't know the height. Okay. The length is 3 times that. So I'm going to let this height be x. This time I'm choosing X to represent how tall that bookcase is. Okay? All right. What did it tell me about the length? Whatever height is. And what did we say the height was? So this is going to be 3x's. Okay? Now why they picked that specific dimension, I don't know. They just did. Okay, so I got some stuff written down here. It's looking pretty good. I'm going to read through this again. Bookcase be constructed as shown in the figure. The length is to be 3 times the height. I have a 60-foot piece of lumber that is available for the entire thing. Find the length and the height of the bookcase. So in other words, I'm going to take this big old 60-foot board and I'm going to chop it up, and it's going to make this part of the bookcase. It's going to make everything. So it's going to make this part. It's going to make this part. This part, and then these two here. Okay, I want to use the same piece of wood for that. So let's see how much we're going to need. So we need this one here. How many pieces of wood do we have that are going to be X? 1, 2, 3. Okay, so I got 3X there. Okay, so that is this one, and this one. Okay, those are my 3 heights. Now, we got left, we have this one here, we have this here, and this here. How long are those? 3 X's. How many of those do we got? 4 of them. Okay, so in this, I got plus, here we use 4 3X pieces of wood there. Okay, so I have 3 here with the talls. I got 4 with those. And when I'm all done, this all has to add up to how much? 60. Okay? So if I took this thing apart, I'd have 3 heights, okay, and 1, 2, 3, 4 of those things. All right, all together they're going to be 60. Kind of looks like those entertainment centers you had to put together with the darn little screw things you turn, and done a few of those. All right, so now we'll just figure this out. So we have 3x here plus, what is this going to give me? Right, this red thing, what's that going to be? 12x's. Okay, equals 60. All right. Notice we're not worried about the back thing they're showing there, because that's made out of some compressed cardboard stuff. All right, so what do we got here? 15x equals 60. Also notice how nice this problem works out, unlike things I make up. Here we go. And what does x turn out to be? 4. Okay. All right, so I figured out what x is. All right, so I wrote an equation, drew a picture, wrote an equation, figured out what x is. Now I've actually solved it, and now I'm going to go back and see what it is exactly that it wants. Find the length and height of the bookcase. Well, I know what the height is. The height is 4. Okay? And from up here, I wrote down that the length was 3 times that, so how much is the length going to be? 12. Okay? So that one is about as complicated as these problems get. Okay, 36 is just like it. If you draw the picture and use it, you'll get it. Okay? I think that's all the ones that we have in there, right? 38 was it, or whatever as high as we went. Okay. Okay. Good. Any questions on, because we're not going to practice these. I mean, this is it. This is our shot at it. So do you have any questions on any of the ones there? Do you see one there that you're not sure about how to do just by glancing at it that you want to talk about? All right then. Okay. Let's see. So that is the end of 2.4. Okay, so there's nothing else there with that one. All right, let's take a look at 2.5. I'm sorry, 2.6. Okay, 2.6, a lot like if those of you who had Math 20, this is in one of the, I can't remember exactly where it is, but it's in there. They do a lot of working with shapes. Okay, so when you take your test, the formulas for all the shapes that I ask you will be on there. I'm not going to ask you to memorize the area of some, or surface area of a cylinder or something like that. The shape will be on there. Okay. There's really no reason for you to memorize things anymore because everybody's got some sort of a phone they can just look it up. You know. So what's the use? But as long as you know how to use it, that's what's important. All right. Let's take a look at just a couple basic formulas here for, so areas, we'll take a look at those. All right, so rectangle is the most basic one. Now, in the textbook, they say rectangle is length times width. All right, and here I'm going to define it as base times height, because all shapes that have an area that is a nice, not circular or curved, is base times height. All of them are base times height. Okay? All areas that way. A triangle, if we took a rectangle, okay, divide it in half, there's my triangle right there. All right, so a triangle area is base times height, but it's divided in half because it comes from the idea of a rectangle, and with this triangle divided in half, so that means you're going to get two triangles in there, so you have to divide in half. All right, that's where it comes from. Comes the whole idea of that. And it doesn't matter where the triangle's height is. You could have a triangle that's like this, and the height would just come on the outside of the triangle like that. Okay, or you could have a triangle that looks like this, and the height would be on the inside of it. All right, but you're always measuring the height, not on a slant. Height straight up and down. Oh, let's see, square. Square is just like a rectangle with all four sides the same. So the base and the height are the same in the square. That's why I usually see the formula. They put a little tiny s, which I'm not very good at making. So the area is equal to s to the second power for a square. But it's the same as base times height. It doesn't matter, it's just that they're the same length. Okay. So those are your basic ones. They also have a trapezoid. Trapezoids you see a lot of because they make the shapes of bridges and rafters and roofs. Okay. So trapezoids are around quite a bit. In a trapezoid, it's still going to be base times height. It just turns out to be that for a trapezoid, you have to go base 1 plus base 2 for the area times the height divided by 2. Okay, so you're going to take the top base and the bottom base, add them up, divide it by 2, multiply it by the height. Again, that's going to be the height, and that's how you find the area of a trapezoid. All right. And again, trapezoids are fairly common because they're a strong shape. They're strong figures. Triangles and trapezoids are very strong. So those are the area formulas. They're on the page
169.
Thank you, 169 for those. All right. The other little formulas it has a circle. Circles have a circumference. That's 2 pi r and an area of pi r squared. Okay, those two get messed up quite often because they're the same formula with the 2, the pi, and the r. It's just where the 2 is. Right. That one's on page 170, and we'll do some examples of these. And then there's common formulas for volume on the bottom of page 171. Talks about a prism. So any type of a box is a prism. And all volume, again, is area of the base times the height. Okay, so all formulas for volume is all area of the base times the height. That's what it is. The problem is figuring out what the base is. Okay, so when you're dealing with a prism like this, it doesn't really matter because no matter where you put it, the base is what it's sitting on. Okay, so it doesn't make any difference. It could be this bottom part here. You could flip it over. You could flip it up. It doesn't make any difference. Those are all the bases. It's all going to work out the same. Where it does make a difference, this one messes a lot of people up, is this one. Okay, we have a wedge. Because this is a triangular shape, the base is a triangle. Okay, the base is a triangle, not the bottom part. Okay, so the base has got to be the triangle. It's a triangular shape, so that's going to be your base. And again, I'll do some examples of all these so you'll see it. Okay, so that's the prisms. All right, then there's cylinders. Volume of a cylinder, area of the base is a circle, so it'd be pi r squared times the height. That's a cylinder. Then for draw a little cylinder out here, nice glass. And then let's see, then they have a sphere, which is just a ball. And the volume for that one is 4/3 pi r cubed. And these are all on bottom of page 171, so if you don't feel like copying them down, that's where they are. Cone. Oops. Just trying to draw. There it goes. A cone is volume equals, again, pi r squared h, but divided by 3, because it's just a cone. Okay, there's also pyramids, but they didn't put that one on there, which is probably good. Okay, so let's do some examples of all these then. Different arrangements of problems that you're going to have. Let's see, we're going to find some areas of shapes. So let's do something like this. Okay, so the first thing we're going to do is find the area of this shape here. All right, so here we have a rectangle and a triangle. So what we want to do is divide these up into two shapes. So find the area of the rectangle first, and then we'll do the triangle, which you always want to do, divide into a couple shapes. Okay, what's the area formula for a rectangle, do we say? Base times height. So that's simply going to be what in this case? 48. Yep, 6 times 8, which is 48. Good. All right, now we have the triangle left over right there. So we want to find the area of the triangle. Find the triangle. What's our formula for the area of a triangle? Yep, divided by 2, correct? Okay, so here again. So now we have to go up to the triangle. Height is 6. Base is 6. Divided by 2. How do I know that? Because this base of this triangle is the same as that rectangle there. Okay, they got to be the same, or it's not a rectangle. So these have to have the same distance, same length. So height is 6, because I told you that right there. That's what that crazy looking number is there. All right. So now to get a total, then I'm going to take the 48 and the 18. And ta-da, there we go. Questions on that? We're breaking it down into shapes.
What is the 66 again?
Because we took the rectangle area, right here, this rectangle area, and we added the triangle area. So 48 plus 8, 18. 66. Okay, so here, let's look at this shape. All right, so we've got 20 going this way from this corner to this corner here. I got 10 here, 10 here, and then 15 going across. Okay? Now, we don't have a formula for this. This is a hexagon, okay, 6 sides. We don't have a formula for it, but we can break it down into shapes. What shapes could we easily break this down into to get our answer? What does this look like? Two trapezoids. Okay? I have a trapezoid sitting right here, right there, and a trapezoid sitting right there. Okay, so if I find the area of those two trapezoids, I'm in great shape. So I'm going to go area of the trapezoid. What's the formula for that one? There we go. Man, I'm glad you're here tonight. Okay, is everybody else kind of seeing what we're doing here? All right, we're taking this hexagon. It's made into two trapezoids. All right. Here, this one here. And this one here. Okay. All right, now we're ready. Okay, so the height of the trapezoid, all right, is this distance across this way. Okay, because that's, right now the trapezoid's kind of tilted on its side. All right, we'd have to rotate it. Okay, and that would be its height. So how much is it right here? Just this distance. We know this is 15 all the way across.
Oh, 7.5.
So that means this has got to be 7.5. Good. Base 1. Remember, it doesn't matter which base you choose to be base 1. We have a 10. And what about this distance going across here? How much is that? 20. So now we're ready. We're just going to take our calculator, and you can just figure this out. If you type it into your calculator like this, as long as you have a scientific calculator, it'll do it for you. 7.5 to parentheses, 20 plus 10 parentheses over 2. All I know is I got 7.5 times 15. 112.5. Okay. All right. So what we did is we took this hexagon, broke it down into two trapezoids, found I had enough measurements where I was able to find the area of it. All right. Use the trapezoid formula. Oh, I forgot one thing though. That's only one trapezoid. Got to times it by 2. 225. Okay, because I had two trapezoids. Almost forgot about that. Okay, 225. Questions on how we did the trapezoid one? Kind of tricky. Read. Oh, yeah. Okay. Let's do one that is, we'll find a volume. Let's do something that is three-dimensional. We'll pick a yurt-like shape with a dome top. So let's see, we'll make this 12. We'll make this 8. Not drawing a scale very well. No, that'll work. Okay, so we have a cylinder on the bottom. We got a hemisphere on the top. We're going to find the volume of it. Okay, so let's do the cylinder one first. Okay, let's pull out our volume formula for cylinder. What does it say it is?
Volume equals pi radius squared times height.
Awesome. So we have pi radius. So this is 12 going across. So how much is the radius?
6.
6. Going to be half of that. What is the height of the cylinder? 8. All right. Here's I'm going to need some help on that. So I got pi times 6 squared times 8. Again, I'm just going to type that in my calculator. What'd you say it was?
I was just figuring out the 6 squared times 8,
Oh, okay.
and then get to the,
4.77.
Okay. So there's the volume of the cylinder. Okay, just type that in. All right. So now we have this. Now we have this hemisphere on the top. So we're going to do volume of a sphere. What's our formula for that?
4/3 r cubed.
Yep. So we have 4/3 pi r cubed. So we got 4/3 pi. And the radius, what about the radius of the sphere? What would that be? Same as the cylinder, absolutely. Okay, so we have 6 there, because there's no overlap or anything. It just fits right on top of that. Kind of like a salt shaker, I guess. Okay, so now I'm going to type this into my calculator. So I'm going to go 4 divided by 3 times pi. There it is. Times. Now I'm going to go 6. Okay, and whether you have the little to the key or whether you have x to the y, depends on what you have. That's going to give you your cubed. Ooh, not that. 904. That's crazy. Wow. Okay. That was just a coincidence. I didn't figure that out. So 904 for both of them. So now we're going to put them together because we've got the whole volume there. Did anybody else get that 904 too? Huh, that's nuts. And there's our total volume. Okay. Whew. So we pretty much used all of the.
Isn't that only half the sphere though?
Oh, thank you. I did that twice now. We only need half of this guy. Let's see. 904 divided by 2. 4.7 divided by 2 equals that. And then we'll add another 904 to it. 1357. 1357. Thanks. Yeah, we have to divide it in half because it's a hemisphere. All right. Do we have to do 55, Marie, do you know?
Nope, we don't. We use 57 through 67 on.
57 through 67. We didn't do 55? Rats. How did I mess that up? Okay. All right. So I'm just going to give you a couple of these to work with, and then you can take your break or something, go stretch your legs, come back, and work on a couple of these. See how you do, and then take our quiz, and we can. That'll be it. That's the plan.
Pyramid, 2.2, 6.5. I just downloaded it since the calculator feature on my phone.
I got the same one on my phone.
Download this.
Just a graphing one too? Or is it just something?
It's just a big it has pi, has
Does that have Yahtzee? Probably.
Okay, let's see which ones we want to do here. 2.6, 177. Got that. I will do one of the circular ones. 14. Let's see. 21 through 27. Okay, we'll do 25's a good one. It's a cone. One like that. And 39 through 40. Ooh, I didn't talk about that.
What's up?
nothing.
39 through 45. I'm gonna do those. Let's see then. Let's see. We did 57. So we're gonna trade this off a
Trying to
little bit.
remember all these is gonna be tough, dude.
What was that? 40. 4 on the line. Let's go with 5. That's such a darn good one. And 54 is a good one. Okay, so here's what we're gonna do. I don't know why I have these ones on there, so toss those out all together, 39 through 44. Don't even do them. Okay? What we're gonna do is we'll trade it. We're gonna replace these ones, which we'll do in class. 51 through 55 to replace those ones, so you get a bargain because you get less. And then do these ones. Does that make sense? Okay, so we're actually gonna do all 4 of these. I wanna see you work on 51 and 55, but you'll get the answers in class for. Okay, don't forget to take a break.
So we're
You're confused?